Hello, I'm Bradley Alisea, and today I'm going to talk to you about community statistics and models. This is the first of a two-part series, and this is the last module of this course. So let me share my screen, and we'll get started. So this will be broken down into methods about how to analyze community data, where to get it, what it looks like, and then we'll talk a little bit about how to analyze it. And then finally, we'll talk about various models you can use to understand it. And then we will conclude. And I want people to think about this outside of this video. I want them to kind of go maybe find some data, try to analyze it, and maybe couple this with some other resources on data science or data analysis of anything of your choosing. So the first part is methods. So say we would like to better understand not only who is participating in our community, but the trends and volumes of participation as well. And we've talked before about analyzing data from your community in terms of understanding resource management. So taking analytics and looking at them in different ways and evaluating how you're doing in terms of your community resource management. But to do this in terms of like more of a data science orientation, we can use a number of source data sets and indicators to tell us when something big is brewing in our community. So we can go beyond the standard analytics dashboard, and we can get raw data. We can take multiple analytics dashboards, and we can create analyses that will tell us something about what's going on in our community. While far from perfect, there are a number of quantitative measures and methodologies one can use to provide insight. So this is, again, I'm going to talk about some methodologies in this session, in this two-part series. And then, but I want you to go and I want you to think more deeply about it and maybe find your favorite models and sources of data. So the first point I want to make here is that open source contributor data, like a lot of other forms of data, is messy. And this article talks about navigating the messy world of open source contributor data. And so if we go to this article here, we can see that there's a navigating the messy world of open source contributor data. They talk about sort of defining your project's contributions to define your data. So they talk about maybe how to define things upstream of the data, like how do you measure a contribution? Well, you have to define a contribution before you can really measure it. Although you can measure it from indicators, to get a really clean measure, you want to define what you're looking for. So this is something that's very important. So most open source projects use sort of idiosyncratic methods, meaning that they don't have a lot of formal methods. And in this area in general, there are no formal methods for analysis. In some academic fields, for example, you'll have certain methods that are used over and over again. People understand what they are. But in open source community management, there's really no standard methods for analyzing this. Now, this brings up a paper, which we'll talk about in a minute. These researchers from the University of Vermont, and they talk about this issue a little bit more. But you have a number of data sources. So data source number one is your GitHub repository and issues. So you can look at your issues, you can look at pull requests, things like that. That's all a source of data. Bug triaging, quality assurance, any of those things, they're all usually recorded, at least in some rudimentary fashion, in GitHub. It produces analytics that tell you about these different activities. Second source of data are surveys. And so surveys are self-reports. You send them out to your community and survey them on different things. But surveys have that same caveat, that you have to define the questions you're asking in order to get an answer that's viable. And this is something that you can segment your community into different use cases or into different audiences. You can use survey results to measure community engagement, event organization, demographics, teaching, and tutorial development. The third source of data are forums. So we talked about forums in another video, where these are platforms where you can guide discussions and conversation. And these forums usually have some sort of analytics function. So but you can also look at things like documentation, writing and editing, localization and translation of the software, and troubleshooting and support. So all those things kind of come with statistics. The fourth source of data are site analytics. So these are things that we would like to see for websites and other types of documents, and then for social media. And then number 5 is legal and finance. So there are other types of data that involve legal and finance. That's probably measured more traditionally, but it's something to think about. Now, going back to this guide here. So this is the paper, Which Contributions Count? An Analysis of Attribution in Open Source. So this talks about what is considered an attributable community contribution. And so in this group, and they're at the University of Vermont, they're talking about, how do you measure a contribution? How do you characterize a contribution? How do you measure it? So, most open source software projects usually acknowledge contributions of text files, websites, and other what they call idiosyncratic methods. These data sources are hard to mine, which is why contributorship is most frequently measured through changes to repositories. And this can be measured in GitHub. Recently, some open source projects have taken to recording contributor actions as standardized systems. And we'll talk a little bit about a standardized system later on in this series. This opens up a unique opportunity to understand how community-generated notions of contributorship map onto code bases as the measure of contribution. So this is a way, and this is sort of a top-down way to look at contributorship and to define what people are doing. And this often transcends things like GitHub activities or going to a specific website or reading a newsletter or whatever. It allows you to record activities and amounts of activity, and there are different ways you can do this. So that's an interesting article. I would read more about that. Then there's this paper, or this article on open source metrics. So this kind of gives a little bit more detail about open source metrics and the metrics that are used to measure some of these things. And again, these metrics can be messy. The data can be incomplete. You really have to define your variables in advance. So you need to do some top-down categorization of your community. So with more information, you can understand how users respond to a new feature, figure out where new users come from, identify and decide whether to support an outlier use case or functionality, quantify a project's popularity, and then other things. And so these are things that are kind of related to usability, but it's something you want to characterize in your community so you can understand what to the sort of a roadmap and what kinds of expertise you have in your community and what kinds of things they would like to make their lives easier. So this is here, this section 2 is discovery. Before anyone can use or contribute back to your project, they need to know it exists. So are people finding your project? And this is where a measure of your page views on GitHub or your page views on your website matter. You can take these simple analytics, plot them out in time, and see what your visitor flow is. And so if you want to increase your visibility, then you have to do things to address that. But that's something you can see from the data. So this is a very simple form of data. Then there's usage. So now, usage is where people are actually using it. Now they're not just visiting your website, but they're using it, using the software, downloading the software. And so depending on what platform you're using or you use, you can collect these data over time. And so this is another example of Git clones graph. Again, this is a simple time series data. It's very coarse grained time series data, but still. And so this tells you more about your audience, tells you more about what you're doing, and then your retention. And we've talked about this in a previous session where, are people sticking around? And this, of course, can be gotten from GitHub as well. So you can see people's activity over time. So there's a lot of time series data here, and these are potential measures that you can use. Then there are potential data sources for analysis. So, measures are great, but you want to have a diverse set of data sources as you can. in order to really kind of understand your community in a multidimensional way. So again, these are things that were mentioned in this article up here. These are potential data sources: Git issues, surveys, forums, data analytics, legal, finance, document reads. In a minute, I'm going to tell you about some other sources, and those are maybe less obvious to people, but we're going to stick with those for now. Now, when you're dealing with community data, you're going to be dealing sometimes with something called personal identifiable data, or PII. And this is an important distinction because sometimes you have data that's just like analytics picked up and tracked. And those are usually accepted to be not like privacy sensitive. So you can take those data and plot them and use them just for insights, but they're rather crude and they don't really tell you a whole lot. Personal identifiable data might be something that's very personal. You have people who come in, individuals that come in, and sometimes they'll be sharing data that's personally identifiable. Sometimes it's in your software itself, if it's like a mobile application, or sometimes it is in the community in which you're recording. And so you need to do things to ensure anonymity and privacy and security. So there's this article on open source projects in the GDPR. So if you're running an open source project out of Europe where you're engaging with Europeans, there are these GDPR rules that you might want to check out. I'm not going to go through those right now. There's this other article on using open source resources. This is for education and evaluation audiences. So this is something for a specific academic audience, but it's still something that they they talk about how to use open source resources. And I won't get into that one either, but just to let you know it's there. Then there's this is for an energy audience, or like in the energy industry. And this is a review of open source tools. So all these talk about personally identifiable data in different ways for different audiences. So you can see that like this is a concern across the world and across different areas of different fields, different areas of interest, different audiences. Okay, now we get into going into a little deeper into GitHub Analytics, because this is an easy source of data. It's a low-hanging fruit. And so this is something that we want to get into a little bit more to understand what we're doing. So you might use the tools that they have in GitHub. And if you go to some of the, there are several tabs in your repository that provide graphs that just come up when you go to that tab, and they plot the data out for you. And that's nice to just kind of take a glance at it. But sometimes you want to be able to take the data and plug it into some other tool like R or some other statistical package. You might want to, or Excel, and you might want to actually look at the data and plot it in different ways. So this is these are 20 tools to help you mine and analyze GitHub and get data. And so again, they mostly provide a lot of like time series data to coarse grained, but there are a lot of tools that you can use. Usually you have to have some sort of API, which is where you communicate with GitHub server. They provide you with the data for your repo, and then you get it in some sort of like, JSON or CSV format. And then you can take and put it in something else. And then, you can make some, insights become available. And so there are different ways you can do this. Sometimes you want to just plot it out, but that's what you're getting in the GitHub GUI. So maybe we want to do other things to it, like transform the data somehow. And we'll talk about that in a little bit, how that works. But there are all these different tools for getting the data from GitHub. There are APIs, there's an archive, there's a torrent. So there are all different ways that this can be done. Then you want to export the GitHub statistics of your own organizational contributor. So this is an article, this is a Medium post on exporting these statistics from your own repository. And so these statistics are often helpful to get the pulse of the GitHub repository, make it possible to have a breakdown of added, removed lines of code, number of commits by contributors. So this gives you a lot of information, and having it all kind of in one place allows you to plug different variables in and plot them out. And of course, you have individual user aliases. So that may be something you want to show people, maybe something you don't want to show people when you're doing analysis of the data. So this is, again, this personally identifiable information issue. So, this is something that you want to be able to get maybe from multiple repositories. So this is why these using an API or using a torrent is important for getting this. And so this gives you a lot of information about how to do this. It walks you through all the repositories in your organization. So your organization may have multiple repositories, and you'll want to evaluate each of those repositories, maybe separately, maybe together. And so again, this is a good reason why you want to export things. And then getting contributor statistics. So then you get contributor statistics. And one of the things about contributor statistics is that's good for GitHub, but if you have people who aren't very active on GitHub, then you don't get to capture those people and their contributions. So this is something to think about. Maybe you know which users, or what proportion of users are using GitHub. You can get a good characterization of those people, but other people are left out. So we'll want to think about that a little bit more later on. But before we do that, we want to talk about maybe other ways to measure maybe usage instead of like contributions to GitHub. And it doesn't, a lot of times the analytics will give you information about forks and maybe clones and stars and things like that, but it doesn't really tell you about people who want to download or view your software. So one way you can do that is to release what they call a PyP package. So this is a PyP, it's a site that allows you to publish things, usually written in Python. They're open source, and they take, you can post your releases. When you have a release schedule and you use some sort of versioning system, you can publish releases one after the other, and this platform organizes them and gives the latest release to the person and gives a description. But most importantly, it captures data for you. And so it captures user data, it captures download data. And so this is what this looks like. So this is for a package that I worked on with some collaborators. So something called DevoLearn. And it's a deep learning software for analyzing microscopy data. And this is something that has it's some limited, there's a decent audience for this type of software. So it's not that we're, extremely niche, but we're also not like a very popular package, like something that would be like a Python library for plotting graphs. It's a moderately decent sized audience. So you can see that we have our downloads every month. We have data that basically gives us weekly updates as to where the downloads are. And we can look at the downloads for the month or the week. And this gives you the latest version, it gives you the required dependencies. So it gives people information about what's needed, and then what the downloads are, download patterns over time at different scales of time as well. So you may want to know what happened in the last month, what happened in the last week, what happened week to week. That sort of comparison where you want to see if people are leaving your, not viewing your thing or viewing your thing, or maybe there's a reason why there's a lull in the action, or maybe there's a spike in interest in your software. You want to know all those things. So that's PyP. That can also be used to collect data. And this is another way to release your software. Given that people will go to the GitHub repository and they can probably clone the repository or fork it, but having a download, especially when you have executable files, this is quite a useful tool. Okay, so we know that people use GitHub, and we said that in GitHub we have certain contributors, and then other contributors are left behind. So another place we can go for data is Slack, and Slack, of course, is a subset of users just like GitHub. So it may not give you every piece, it may not be as comprehensive as you would like, but it gives you this sort of, it gives you nice message data about how many messages have been sent by each user. So this is, again, something that we could look at to see what general patterns exist in the community. So this article is on use analytics to increase Slack adoption maturity. So this article, actually, this is a video, and this just kind of talks about like how you can use analytics to, improve your Slack team, your Slack part of your community, draw people in, get them recruited into the platform. And then, the data basically are the number of reads that people make in different repositories or in different channels. And then those channels are, you can assess which channels are popular, which are less popular, which ones you might want to promote, which ones you want to post things in to grab people's attention, and these sort of things. There's user data that doesn't need to be downloaded, that you can just see in the interface. For example, at the top of every channel there's a number of members. You also have things you can download, which is like the number of messages over a certain period of time, usually all time, but I think you can download it by month or year. So it tells you a lot about who's engaging with your Slack community. And so this is another one, understanding the data in your Slack Analytics dashboard. This is an article for the Slack support. And so it tells you a little bit about so this is membership, total members, claim members, weekly active members. You probably want to know like how many people are engaging week over week versus like total people who are in the Slack but maybe don't do anything. So these are things you can find. Active members, messages and files. And then this is the messages. This is maybe pretty valuable data, as we'll see in the second part of this module, that you can analyze these messages, and they actually have some interesting, there are some interesting statistical signatures that I'm going to give it away. And then number of files uploaded, where people are reading, where messages are sent. These are the different channels and how they're used. And so these are all things that you can get. And I think if you pay for Slack, you get more than if you don't. So I'm not going to go through all these, but just suffice it to say there are a lot of potential data points there. So that's Slack, and we'll come back to that later in terms of how to analyze that. But I want to talk about time series analysis, because a lot of these data are in time, or time series data. And time series data are interesting because they're unique with respect to data analysis. So one thing GitHub and many blog analytics engines allow you to do is examine data over a specific time intervals. So we talked about this. So you have weekly, monthly, yearly, all time. And these are time series that have maybe are kind of coarse grained, so they may be once a week or once a day. So they're not moment by moment records, but they do give you this time series data. And so this provides us a graph of aggregate data over a temporal series, which means you have this series in time, which can be good for understanding obvious trends, but it looks quite noisy otherwise. So if you look at a time series, one of the things you'll notice is that there's a lot of variation up and down. And that can be interesting, but it's also not very informative, because a lot of times it's noisy. It's noise, it's variability that isn't really that interesting. It's has a lot of different aspects to it. And sometimes you can do something called smoothing it out to get rid of that noise and see like the real trends. So you're really interested in the real trends. You don't care about this where the series bounces up and down. You want to know, what might happen, say, in one period of time versus another period of time. What's the average? What's the trend? So all those things can be done in time series, but the data have to be treated in a different way than what you would do with normally distributed data or IID data. So if you're familiar with bell curves, that's IID data. And so this is a different type of data. So extracting these data from sources can be done either manually or using command line tools. This is exporting GitHub Analytics to CSV. This is an article on this. So once the data is extracted from this file, you must first smooth the data to remove noise. So smoothing is really taking the points, neighboring points, and averaging across them, or using some other type of transform. And it gives you a number that's refined. So if there's a lot of variation up and down, it'll take an average and it'll give you a series that's maybe in between. But that, a lot of that variation isn't real, it's just kind of noisy. It's like sometimes people will visit, throughout the day, and you won't get an even number of people every hour, but you get an average number of people, say, for an afternoon. And so this is really what you want to know. You don't really care about, like, if people showed up after lunch or then after their post-lunch period or towards the end of the day. You don't really care about that so much. You care about what happened that afternoon. So that's one way to smooth your data. And because the points are dependent, and this is important, the points are dependent next to one another. You can do this operation and it makes sense. So, time series, the points are dependent with respect to how close they are to one another. So if I sample at 1 o'clock versus 2 o'clock versus 3 o'clock, there's a time dependence there that I can average over and smooth over, and it gives me better data, essentially. And so your choice of smoothing techniques depends on your source of noise. You can use just something that just kind of is like a low pass filter, or you can use some other type of averaging or other things, and you can get rid of this. So this is something that you'll want to do in another platform. You won't be able to do it in the analytics engine, but it's worth doing because it gives you better data. And so if you have a lot of periodic fluctuations, for example, if most contributors come in on the weekends, you might want to smooth the data out over the week, or you may want to just window the weekend and take it out. Another way to do this is to window the data by day. So you'll want to take the sort of smooth out the values for the day, find an average, find a variance, and then use that window for one day, and then use that to compare with another day. So this is a way to do this with time series data. So the data can be segmented into overlapping windows, meaning that you want to overlap the windows so you don't miss any points. And then you want to compare meaningful intervals. So you figure out what the meaningful intervals are, you window the data, you transform the data, you smooth it out, you find some descriptive statistics, and then you compare. You might also use tools such as frequency or autocorrelation analysis to discover trends and the smoothed and segmented data set. So you'll want to be able to do something like autocorrelation, which is finding the relationship between points in the data set in time. You might want to do things like find a common frequency in the data set. So say there's like something that happens every day at 2 o'clock in the afternoon, and it happens that day after day. You can find that using a frequency analysis. Whereas, if you had a lot of noise in your data set, you wouldn't necessarily be able to detect it very well. It would look maybe interesting, but you wouldn't know what it was. So this is just a way to discover trends. This is something that a lot of people just talk about, when people look at like analytics dashboards, they can, this is interesting, but you can really find features in here that really mean something. So this is why I'm going through this in such detail. More traditional hypothesis testing is also an option, but remember the time series data is dependently distributed. So you can't compare like 2 points next to one another and say that they're independently distributed. They're going to be dependently distributed. You can compare 2 days over one another, or one day to another, but this is after you like process the data and there's some segmentation of the data. So this is something that, this is an example of user data. This is pull requests, and this is issues. So this is from the Rockwire repository. This is the Illinois App Repository, the Rockwire organization on GitHub. And so you can see that they give you some basic information about pull requests merged, and pull requests closed. And they give you these numbers. And these numbers are plotted out here. So I think that's, yeah, so we're getting these plots. And then there's this number, this percentage is down. So it's down 19%. This is month over month, down 18%, down 33. Now this happens to be from a period where they just got done doing a major update. So obviously everything's going to be down with respect to when they were doing the major update. That's obvious. But of course you have to know that context in order to get something out of the data. And then like, you can see that there's a lot of noise in this time series. There's also a lot of fluctuation. And it may tell you something about when people are coming in to do pull requests, or it may tell you something about like days where people are doing this, or, there are different things you can find. And this is just in the dashboard. You can download the data to do more detailed analysis. Same thing with issues. This time series is, look how noisy it is. And again, this is issues and issues closed. So the number of issues closed is up, number of issues is down, because they're done with a lot of things and they've been working on closing things out. And then, there's this lull in activity after something like that because everyone's tired. And so that's reflected in the data. But again, you see it's very noisy. And so you may want to refine the data some to give additional insight. Okay, that's all for this section. Be sure to stick around for video number 2 in community stats and models, and I'll join you there. Thank you.